Geospatial data analysis, GIS, geocoding, and spatial statistics. Geospatial data analysis has become an increasingly important tool in understanding the relationships between people, places, and things. The availability of large datasets, along with advances in geographic information systems, GIS, geocoding, and spatial statistics, has enabled researchers to map and analyze spatial patterns and relationships in ways that were previously impossible. In this article, we will provide an overview of GIS, geocoding, and spatial statistics, and their applications in geospatial data analysis. GIS. GIS is a computer-based tool for mapping and analyzing spatial data. It allows users to create, edit, analyze, and visualize spatial information in a variety of formats, including maps, tables, and charts. GIS technology combines the use of hardware, software, and data to capture, store, manipulate, analyze, and present geospatial data. The technology enables users to identify spatial relationships and patterns that may be difficult to identify using other methods. GIS can be used in a wide range of applications, including urban planning, environmental management, natural resource management, epidemiology, and many others. For example, GIS can be used to map the location of hospitals and clinics, assess the spatial distribution of disease outbreaks, and identify areas that are at risk for natural disasters. Geocoding. Geocoding is the process of converting street addresses or other location identifiers into geographic coordinates, such as latitude and longitude. Geocoding enables users to map and analyze spatial data using addresses or other location identifiers as inputs. Geocoding is commonly used in applications such as online mapping, routing, and location-based services. Geocoding algorithms typically use a combination of address parsing, database lookups, and spatial analysis to determine the geographic coordinates of a location. Address parsing involves breaking down an address into its component parts, such as street name, city, state, and zip code. Database lookups involve searching a database of known addresses to find a match for the input address. Spatial analysis involves using GIS tools to locate the input address on a map and determine its geographic coordinates. Spatial statistics. Spatial statistics is a branch of statistics that deals with the analysis of spatial data. Spatial data is data that has a geographic component, such as latitude and longitude coordinates or street addresses. Spatial statistics methods are used to analyze spatial patterns, relationships, and processes, and to develop models to explain and predict these patterns. Spatial statistics methods include exploratory spatial data analysis, spatial autocorrelation, spatial regression, and spatial interpolation. Exploratory spatial data analysis involves visualizing and describing spatial patterns in data using tools such as scatterplots, histograms, and maps. Spatial autocorrelation is a measure of the degree to which spatially close observations are more similar than observations that are further apart. Spatial regression is a type of regression analysis that incorporates spatial information into the model, such as the spatial relationship between predictor variables and the dependent variable. Spatial interpolation is the process of estimating the value of a variable at unsampled locations based on measurements at sampled locations. Applications of geospatial data analysis. Geospatial data analysis has many applications in a wide range of fields. Here are a few examples of how GIS, geocoding, and spatial statistics are used in practice. Epidemiology. Geospatial data analysis is commonly used in epidemiology to investigate the spatial distribution of diseases and to identify patterns and risk factors. For example, researchers may use GIS to map the location of cases of a particular disease and to identify hotspots or clusters of cases. Geocoding can be used to link cases to specific addresses, which can help to identify environmental or social factors that may be contributing to the spread of the disease. Spatial statistics methods can be used to identify spatial patterns and to develop models to explain and predict the distribution of the disease. Urban planning. Geospatial data analysis is also widely used in urban planning to analyze and visualize spatial relationships and patterns. For example, GIS can be used to map the location of different land uses, such as residential, commercial, and industrial areas. Geocoding can be used to link demographic data to specific addresses, which can help planners to identify areas with particular demographic characteristics. Spatial statistics can be used to identify spatial patterns of land use and demographic characteristics, and to develop models to predict future trends. Environmental management. Geospatial data analysis is also used in environmental management to analyze and visualize spatial patterns and relationships of environmental data. For example, GIS can be used to map the location of pollution sources, such as industrial facilities, and to identify areas that may be at risk of exposure to pollution. Geocoding can be used to link environmental data to specific addresses, which can help to identify environmental justice issues. Spatial statistics can be used to identify spatial patterns of pollution and to develop models to predict future trends. Conclusion. Geospatial data analysis has become an essential tool in many fields, from epidemiology to urban planning to environmental management. GIS, geocoding, and spatial statistics provide powerful ways to analyze and visualize spatial patterns and relationships, and to develop models to predict future trends. As the availability of geospatial data continues to grow, geospatial data analysis will become even more important in helping to understand the relationships between people, places, and things.